Example C. Use cylindrical shells to find the value of the solid, obtained by rotating about the x-axis, the region under the curve y equal to square root of x from 0 to 1. So this is the region under the curve y equal to square root of x, okay? And x go from 0 to 1. Okay, so that's, and you rotate about this x-axis. So we're going to get a solid like this, okay? Now we use the shell method to do it, okay? So draw a nice segment which is parallel to the axis that you rotate about. So this is a nice segment. And you can make this a thin rectangle. So imagine this thin rectangle rotate about this x-axis, and you get a thin shell like this, okay? So let's think about what's the value for this one thin shell here. So that will be circumference, which is 2 pi times the radius. The radius over here is going to be the y coordinate of this point, so it's 2 pi y. The height for this shell, remember when you put the shell sideways, okay, this way, this corresponding to the height, okay? So the height for this shell over here is from here to here, so the distance here will be 1 subtracting x, okay? The thickness of this shell is a change on this y direction. So that's dy, delta y, okay? And we add all those shell up, use integral. So the y over here go from 0 to 1. So that's the integral for the value for this solid here. Now, because this is an integral with respect to y, we want to express everything here in terms of y. So express x in terms of y. X is this point on y equal to square root of x. So y is equal to square root of x. So solve for x. X will be equal to the square of this y. Now we substitute. So this becomes y squared over here. Now we just need to evaluate this integral. Take this 2 pi outside of this integral and multiply this y in. So that will be y minus y cubed. Antiderivative of y is y squared over 2. Antiderivative y cubed is y to the 4 over 4. Substituting 1 and 0 into y, you get the result is pi over 2. Now in this problem, the disk method is actually simpler. Okay, you can try that. Okay. Example 4. Find the value of the solid obtained by rotating the region bounded by y equal to x minus x squared and y equal to 0 about the line x equal to 2. So y equal to x minus x squared, if I factor this, it's going to factor into x times x minus 1. So I know the x-intercepts are 0 and 1. So 0 and 1. So this will be a parabola open down, have this 2 x-intercept. Y equal to 0 is this x-axis. So this is the region bounded by the true curve. And now you're going to rotate this region about this vertical line x equal to 2. Okay, so rotate about this vertical line. So you're going to get a solid, okay? So to imagine this solid, you can draw a symmetric image of this region on the other side of this vertical line. And then you can draw this circle, try to visualize it, okay? So draw a nice segment parallel to this vertical line that we rotate about and make it a thin rectangle, and you can draw this thin shell over here. So what's the value for one thin shell here? Let's label this point on the curve x comma y. So the circumference of this circle over here is 2 pi r. Okay. And the height for this shell here corresponds to the y coordinate, that's y. the thickness of this shell over here, it is delta x. So that's dx. So that's for one shell. Now we integrate to put all those shells together to get the whole value. So x over here will go from 0 all the way to 1. So it's this integral from 0 to 1. Now this is the integral with respect to x. We want to express all of this in terms of x. So the r over here is from here to here. So we will subtract the x coordinate of this with the x coordinate of this. The x coordinate here is 2, x coordinate here is x. So r over here will be 2 minus x. The y over here is equal to x minus x squared. Now we have expressed all of this in terms of x. Now we can take this 2 pi outside this integral and we expand this, multiply this out. So we got this. Now we find antiderivative of each one of this. We got that. Now substitute x to be 1 and 0 in. Do the calculation. That turned out to be pi over 2. So that's the value for that solid over there. Okay. Now, some student asked me in the homework about this, about the height. They have question. Well, for the shell. Now, if the shell is put it this way, then the height will be this from here to here. Okay. However, if you put the shell sideways like this, then the height is going to be this one over here. Okay. So that was one question a student had. So that's the end of the lesson.